the talk today is about tiny part of what I consider
for the video instead.
Okay, video. Okay, so this is me, Viktor Farcic. I work for CloudBees, already mentioned, company behind Jenkins. I'm also one of the Docker captains, meaning that I'm very active in both communities. Docker captains is kind of program evangelism, something like that. Couple of books. I'm not going to sell it to you today. So let's speak about today. The subject is quite big. I cannot speak about everything I would like to speak about DevOps, so I'm going to concentrate on Jenkins, and I'm going to concentrate on Docker together with Jenkins to form a continuous deployment pipeline, right? So Docker, anybody using Docker here in production? Put your hands down if it's not in production. Doesn't count. Okay, 2 guys. Excellent. Yeah, until recently nobody would lift their hands, so it's moving kind of forward. So I'm not going to spend much time in Docker. You probably at least have some broad idea about Docker. You've heard about Docker, right? So it has Docker engine, Docker machine. Docker engine is a way to specify your commands in a declarative way in YAML file. Docker machine, a way to create virtual machines relatively easily. For Docker, Docker engine is what runs container, Docker machine, virtual machines, Docker compose YAML file where you specify all the arguments you would need for Docker. Docker registry is equivalent to Nexus. If you're using Java, it's a place where we store images. And Docker Swarm, which will be the subject of what I'm going to speak about today. So I'm going to start. I don't like speaking for a long time, so I'm going to start doing some live coding. Doesn't work. Does it work?
It works.
Okay, excellent. So let's see. Before we move into Jenkins, I'm going to set up a cluster on my laptop to begin with 3 servers, and they're 3 servers that are gonna run in a cluster. So I'm gonna do. At the moment, ignore this command. It's not important. The only thing that this command does is that it shows how my cluster looks like. This is how my cluster looks like at the moment, meaning there is no cluster. It's empty, right? Just so that you don't think that I'm cheating. So to create a cluster, do you see this? Is it too small? You want me to make it bigger? A bit bigger. Is this now good? Do you see it now? Yes, okay. So to create a cluster, all I have to execute is Docker Swarm init, give it the address of a first node, and that's about it, right? That's how I create a cluster. And it gives us some information, and we're going to go into, and you can see here's my cluster. It has 1 server, right? It's as easy as that. So let's see. A cluster with 1 server, that's not really too big of a deal, so let's add 2 more. To add additional nodes to the cluster, all you have to do is Docker Swarm join, give it a security token that I got before. That's the one. Give it the address of a server and the address of some other node in a cluster so they can join together, right? So I execute this for additional 2 servers, and I get my cluster. Now this is 3 nodes, right? Getting somewhere. And if you don't like UIs, as I don't, you can get the same information from command prompt, right? Docker node ls gives you the list of all the nodes in your cluster. So I'm going to run a first service. To create a service, all you have to do is Docker service create, give it some name, expose some ports. I'm going to speak about ports later on in more detail. And in this case, I'm mounting a volume. PWD means that current directory on my host will be shared with this directory inside of a container, right, for persistence reasons. Assign some amount of memory and specify which image you want to be the service. And by the way, this is the registry I mentioned before. This is where I'm going to start putting images very soon. And if you worked with Docker Compose before, you would probably see that it actually takes some time and it would spit some information. Swarm does not just send you acknowledgement. I understood what you want. it's going to happen sooner or later. The difference between Swarm, or if you run with the Docker Compose on a single server, stuff like that, is that you don't tell Swarm what to do, you tell him what is the desired state you want to accomplish. And the desired state that I wanted with this service is that it is running and it has 100 megabytes of memory. It runs somewhere where there is 100 megabytes of memory available. If I go back here, Swarm, I'm not specifying where it's going to run. That's the job of Swarm. That's the job of what cluster schedulers do, right? Imagine that this is the kind of 100 nodes cluster or 1,000 nodes cluster. You wouldn't probably start deploying it to specific servers. So Swarm decided to put it on Swarm 1. And if you wanna, I can run Docker service PS and the name of the service, and I get a bit more information. So this is the name of the service, this is the image. This is where it's running at the moment. Desired state is running, and the current state is just as well running for 52 seconds. So I'm going to now continue creating two networks. I'm going to explain later on, if you don't know what overlay network is, I'm going to explain it soon when we get to the example. Just for the moment, remember that there are two networks created. One is called PROXY, the other one is called Go Demo. We'll get to that pretty soon. So I'm going to start create my next service. Now this is Docker service create. Again, same thing. Give it some name, and this time I'm going to attach it to a network, and it's going to be Mongo. Now pay attention that I'm not exposing any ports. This is a Mongo database. I'm not exposing any ports. This database is going to be inaccessible to anybody except other services that run in the same network, right? So it's completely inaccessible unless you're in this case, in Go Demo network. So service will be created. I can list my available services with Docker service ls, and it's see that at the moment replicas of Go Demo DB is 0 because it still did not start. It will start probably soon. I'm not going to wait for that. I'm going to create my next service. I think the last one. Now this is the service I created. It's written in Go. It's only for demo purposes. The difference here is that two things. First, I'm specifying environment variable DB that has some value. Now, this value is the same as the name of the previous service that I created. And the code of this service does not have any configuration file or anything. It just uses this environment variable to know where is the database. And database is in a network endpoint called GoDemoDB, right? It's similar to as if you have a DNS pointing to that service. I'm going to attach it to the same network GoDemo like the previous one. I'm going to add it also to the network proxy. You will see very soon why. And finally, this is the name of the image of my service. And it will run soon. So let's see the process of this last service. It is still preparing it. Let's see, it's starting and still starting. The service has a health check, so every 10 seconds it checks the health of the application inside, of the service inside. So approximately 10 seconds later, yeah, it's changed the status to running. So it's running somewhere inside of a cluster. No, I'm using this for demo purposes visualizer. You should not worry about where it's running. Swarm takes care of that, but just kind of to visualize it so that you have some idea, it distributed containers within a cluster evenly at this moment. So, the last thing I will need is, I'm going to create a proxy. Now, those services that I created by now, they don't expose any ports, they're inaccessible to anybody, right? But I still want to have a proxy sitting on top of it, reverse proxy, that is going to be the single point of access. It's not going to be single, I'm going to get there as well, but it's going to be a point of access that will redirect forward requests to one service or another, right? Based on URL. I mean, everybody probably, you have a proxy, right? You know what reverse proxy does. So I'm going to create a proxy. If you want to check it, it's a project based on HA proxy. You can check it on GitHub later. Not much time to explain it right now. Okay, so my service is running, the proxy service. I'm going to reconfigure it to the additional value of this project on top of HA proxy is that allows me to reconfigure the service dynamically, right? Instead of changing configuration file, which is what I'm going to do. I'm going to reconfigure it. Yeah. So I reconfigure my proxy to take this service into account. And finally, if I send a ping to my service, it's working, right? Everything is nicely integrated. Now, what you should know, I'm not sure whether I have slides for that. Okay, what you should know is that, let's see, again, the proxy is running on Swarm 2, right? But I pinged Swarm 1. The reason why that works is that actually when you open ports, as I did for this proxy service, the port is open on every single node of your cluster. So you have no single point of failure. You can enter through any of the nodes, and Docker networking, or to be more precise, routing mesh, will redirect the request from server A to server where a proxy is running. If you have multiple instances of a service, it will not only forward the request, but it will do load balancing as well, right? The only thing that the proxy itself does is just routing based on URL, nothing else. The rest is all done by Docker networking. But since this is not the subject really going deep into Swarm, I'm going to continue because this is about Jenkins today. The reason why I did all this is that I wanted to set up something that would look like production environment so that I can show you continuous deployment, how it would look like. So continuous deployment, you know what, are you doing continuous deployment delivery, anybody? Yeah, every commit goes to production, or put down your hand. Okay, one guy. Okay, moving forward. So it's very, very, very simple to explain, hard to do. Now, continuous deployment in a nutshell, it might differ from one organization to another. You check out the code, run some tests, build something, run some other tests, push it to a registry, deploy it to something similar, almost the same as production, test it, deploy it to production, test it again, right? And you do that on every single commit. Even if you're not doing continuous deployment, you might be doing continuous delivery, which is exactly the same process. It's just that there is a button that somebody might needs to push and say deploy, right? But still, no manual actions between a commit and production, except maybe pushing the button, right? And the button that there is not for technical reasons, it's only for business reasons. Maybe your marketing department does not want to push that feature to production yet, right? So, but I have extra requirements. First of all, when I work in projects, I really don't think that anybody should tell a team in charge of signal service, and when I say a team, I mean 6 to 8 people. Anything more than that is not a team. It's a school bus. It's a classroom. It's a factory. So I like that the team I'm working with, it can choose any single programming language, because depending on a task that you're supposed to accomplish, you might choose one language or another. Because Java is good for some things, Go is better for other things, Node.js is good for some other things, right? You want to choose the tools you use, and programming language is a tool. And that's my requirement for continuous deployment. So any language. On top of that, any framework. I'm talking about microservices world now. If you're into monolith, that might seem confusing because you don't choose languages. Not dependent on infrastructure. One of the things I hated the most in the past, you finally finish, and then you open a Jira ticket and wait for a month, a week, a day is even too much, kind of. So we want to get rid of that and make everything as a service and be fully automated. Immutable deployments, very important. That's what we get, one of the big things with Docker, right? Because without Docker, unless you use some nasty stuff with virtual machines, what you're testing in one environment is not the same as what you're deploying to production, right? You're not testing, you put in production untested software, right? Or partly tested software, because production and your testing environment and your laptop is not the same. That's what we are trying to do now is immutable deployments, meaning that once I build something, that is unchangeable. And that something is not a jar file, it's a whole stack, everything from the beginning to the end, full stack, unchangeable, as if I wrote a CD and plugged it into a machine. Minimal time between the steps. I really don't think that we should have too much empty space between different phases and stuff like that. Everything needs to be automated and freedom to innovate, which is the result of being able to code in whatever you want, whatever you think is good, not whatever you want, choose frameworks and all those things. And the reasons why I like those extra requirements because I'm impatient. I don't like waiting for other people to do stuff. I don't like to depend on other people, unless actually other people are people working very closely with me in the same team. I hate handovers. You know, department, you have one department sending it to another department, sending it to another department, and you forgot what happened in the meantime. I hate doing. That's one of the main reason, and I think he knows why I entered into whole automation and all those things. Things is that I hate doing the same thing I did today as I did yesterday. So Jenkins, probably everybody knows what Jenkins is. I don't need to speak about Jenkins, right? You know what it is: continuous integration, continuous delivery, continuous deployment. It can be used to orchestrate a bunch of stuff. It's really awesome, and so on and so forth. Do I have time? Yes, I do. Excellent. And stop me at any time. It's okay if you stop me. I tend to speak very fast when I don't have enough time. So let's see. How do you run Jenkins now? Do you run it in a dedicated server? Do you run Jenkins? Right? What happens when Jenkins fails? You run around like chicken around the office, right? Screaming around. Okay. So I'm going to create another service, right? And it's the same thing as what I did before. It's still the same cluster, right? It's just another service. Said Docker service create, give it some name Jenkins, give it 300 megabytes of memory, expose some ports, some optional arguments. They're not really that important. Persist directory on a host, and imagine the directory would be NFS volume. To go simple, we can go later discuss more complicated options like Flocker and so on, but persist it somewhere because basically, unfortunately, Jenkins is a stateful application. And finally, this is my Jenkins Alpine, right? Alpine, always whenever you see in Docker Hub something Alpine, use Alpine, don't go for anything else because they're much smaller images, much lighter than anything else. And let's see, did I run this? Yes, I did. Let's see whether my Jenkins is up and running. Yes, it's already running for 45 seconds. It's faster than me speaking. So let's see. Okay, here I go. There's my Jenkins service running. Somewhere inside of a cluster, right? It's as easy as that. So the reason why this is not a fresh installation is because I did it a couple of hours ago. So Jenkins files were persisted on my laptop. Otherwise, I would need 2 more minutes to set it up. So let's see. Visualizer. Jenkins is running somewhere. Nobody knows where. Is it running? Yeah, it's running on node 1 here, right? It's my cluster. So let's see. I'm gonna skip. I installed, it's already, since I did it before and then destroyed all the machines, but Jenkins files are persisted. The only thing additional that I did, apart from installing the recommended, you use Jenkins 2.0, you know that now there is a setup page which allows you to define plugins you want to use. The only additional plugin that I installed is Jenkins Swarm. And if you used Jenkins Swarm, you know what Jenkins, you passed the exam. Okay, Jenkins Swarm, nothing to do with Docker Swarm, allows me to register agents without going to the master. So they will auto-register themselves, right? Since I don't like UIs, I like automation, I want them to register themselves in a fully automated. And that's what self-organizing Swarm plugin modules gives you. So let's see now. Now what I'm going to do, I'm going to execute Docker, I'm going to execute this command. This command is gonna destroy my Jenkins container, right? It's gonna remove it. Docker rm and find the ID of a container. So that will be a simulation. What happens when Jenkins fails, right? So let's see what happens when Jenkins fails. Let's see. When Jenkins fails, we have something like this. We have here the previous instance that was running before is now changed the state. Change the state to shut. Okay, this one changed the state to shut down because it failed 4 seconds ago. And Swarm automatically brought up a new instance of Jenkins because you remember what I said about desired state? We did not tell Swarm to run Jenkins. We told him that we want it to be running no matter what happens. If I destroy the whole server, the result would be the same. All containers from that, all instances of a service from that server would be transferred somewhere else, right? So you have fault tolerance for free, right? And you don't need to scream it all out when Jenkins. Yes.
If you display the container here,
yes.
You don't have to download it again. Just to have the image.
It depends. If the image is already pulled on a server where Swarm will decide to run a new instance, then it will not pull it. If the image was not pulled previously on that specific server, then it would pull it before running a new instance. So you would have, now in most cases, you would probably have your images in your private registry on your private network, right? So pulling an image would be a second. Yeah, what I did before I came here, yeah, I should, so it doesn't sound like cheating. The only thing I did only two things. I created machines, but not joined them to only machines with only Docker engine, and I pulled all the images so that you don't wait eternity, and I never know how the network will be. So that's the only two actions I did at home, right? I pulled the images so that you don't wait for it. But in my home, it takes a couple of seconds to download Jenkins. Maybe 10 seconds, because Jenkins is one of the biggest images, but still very, very fast. If it would be in your own registry, it would be a second because it's internal network and all those things. So let's open Jenkins. Let's see whether it's working. You know, when I do live demos, something always fails, so you need to expect that. Yeah, it works. And since I persisted state on outside the container, everything is still there as it was before. So let's see. Now, the only thing what I'm missing now to have a fully operating Jenkins is I need agents, right? I already explained that at the moment I have Docker Jenkins Swarm installed, so I'm going to create. First thing, what I'm first going to do is I'm going to enter into one of the machines that I haven't used yet. I'm going to create a directory workspace. Just this is where I'm going to persist my workspace, right? And I'm going to create a new cluster because I like to have my build tasks in a separate cluster only so that they don't affect production, right? So it's a separate second cluster, right? And I run the same thing, Docker Swarm init. I initialized a fourth server, in this case, as the first server of the second cluster, right? So what I'm going to do now is that, again, I'm going to run the visualizer so that you don't think I'm cheating. Here it is. This is my cluster, second cluster, right? And where is this? And so next thing I'm going to do, I'm going to run. I told you that I have that on Jenkins I installed the Jenkins Swarm plugin. Now, in order for agents to become members to join a master, you need to run something called Jenkins Swarm agent, something like that, right? In normal way, a traditional way would be that you run a jar file on your server and it would auto-register itself on a master, right? It's just that this time I'm going to run it as a container. Again, I'm going to run it as a service. So Docker service create, give it some name, agent, some command options, like this is where my master is. This is my user and password, one of the administrative user and password. I'm going to give it a label Docker, and I'm going to set it up to have 5 executors, right? Everything is a service. Mount some volumes. We can speak about them later. The only thing is that I'm mounting Docker socket, so that actually Docker commands inside of that container, not executed inside the container, but on a host. Docker inside, if anybody told you Docker inside Docker is a good idea, he has no idea what he's talking about. Never do that. Huh?
It's better to share the socket.
Yeah, definitely. The workspace for persistence, and this is where my SSH keys are if I need them, right? But what is really important and new here is that I'm going to run this service with the mode global. What this mode means is that with this mode, Swarm will not put containers somewhere. Swarm will create an instance of this service on every single node of the cluster, whether it's one node or 1,000 nodes, each of them will have the same instance of the service running, right? So global mode, one server cluster, right? And we look at the processes. You can see that it's preparing, 5 seconds, preparing, starting. It's already running, right? I set up my agent. Now you might say that I'm cheating, so let's double check whether that's really true. Yeah, you can see that one agent registered here, right? And it has some strange name. You don't care about it, but it's agent as anything else in Jenkins. Okay. So now that I have a single agent, because I have only one swarm, one node in a cluster, let me add one more node to the cluster. Again, I'm going to create a directory, get the token, security token, and join this second node to the cluster, right? Docker swarm join, all the things that I did before when joining a node in a cluster. Now, this is where global mode kicks in. I'm not going to run anything specific for the agent in this node because since it's already global, Swarm detected a new node in a cluster and automatically ran the second agent, and it's already running for 8 seconds, right? So I have 2 agents. Don't believe me, let's double check. Here you go. Second agent is there. So I can adjust the capacity of my Jenkins basically by adding or removing agents. If you're running on cloud, you might want to not only add new nodes, you want to remove nodes, save some money depending on the load and all those things, right? But the point is that you can add nodes at your will like this. I mean, if it's in AWS, it would take 15 seconds or something like that to spin up a new AMI, but that's about it, right? So now this is not very interesting. What I'm going to do is, sorry for this, I'm going to get the IP of one of my cluster nodes, any production, first cluster. And I'm going to create, so I'm going to set up here, I like to use environment variables all around, and in Jenkins, this is just environment variables that tells me where my production is, right? Nothing else. And the name of one of the nodes are not really special. So let's see. And the last thing I need, again, a registry where I'm going to push and pull images from, right? I'm not going to bother you. Another service, Docker service create. It's going to run somewhere inside of my second cluster that is used for building, running tests and all those things. So let's see. Now I have, on one hand, I have production cluster with my services, databases, all those things running. I have Jenkins also in the production cluster, and I have my agents running as a separate cluster, right? I have fully set up environment of everything that I might need for continuous deployment, delivery, integration, if you live in 1999. So what we really want is every commit goes through a fully automated pipeline, is deployed to production. I'm not saying that you should all do continuous deployment, nor continuous delivery. Not everybody should do that. But I dislike when people just throw in names saying I'm doing this when you're not. If you're doing continuous delivery, you have no humans involved in a process after a commit, right? That's by definition. You can quote me on that if you want to. No exception. The only intervention, human intervention in continuous deployment pipeline, delivery pipeline is when something goes wrong, right? You have a bug to fix. If you have human intervention, that's great, but you're doing continuous integration, just to clarify terminology. So everything automated, all those steps automated, right? So let's see. Now to do my whole pipeline, right? I'm gonna soon create a job. I already have a job in Jenkins. Anybody, are you using pipeline, Jenkins pipeline? Okay. Those of you who did not lift your hands, but you're using Jenkins, switch to pipeline because we want our jobs to die, horrible death, right? And to die as soon as possible. As soon as possible in enterprise companies means 30 to 40 years, right? Because they don't change. That's a separate issue. So let's see, you remember the steps I told you, check out the code, do this and that, right? In the pipeline terms, and by the way, there are different people have different preferences, how they write their pipeline codes, how they use Jenkins in general. I'm not very fond of Jenkins plugins. right? Unless they add a real value. Many of them do, right? When a Jenkins plugin is gonna allow me to remove one line of a shell command in favor of a plugin, that's not a good plugin. All right, if you're recording this, I never said that. So I'm gonna use Git plugin because it does add the value. It would save me from 4 lines of shell script to check out the code from GitHub. Then I have something called staging. I'm gonna show you what stage means. It's mostly for visualization. My first stage is gonna be unit for unit testing or pre-deployment testing. And I'm gonna run all my unit tests. Now, when I do this with other teams, I would make a naming convention, say, team, you're a team, right? I don't care how you test, I don't care what you do to test. All I need to know is that there is a service defined as Docker Compose that is called unit. That's a naming convention. Beyond that, it's up to you to define what your unit tests are. You know better than me, right? So it will execute some unit tests. In this case, it will do some unit testing on a Golang code. I'm not teaching you Go, so that's about it. If it's successful, it will build a Docker image for this service, right? It's a new release. Now, once I build the image, I can go into staging. Staging, again, naming convention. I agree that we're going to call a service. We're going to have 2 services for staging. One is going to be called staging dep for staging dependency that will bring up all the applications that this service needs in order to be tested. In this case, all the applications means the service that I just built and a MongoDB, but in reality, you might have a more complicated situation. If you have too complicated situation, then you should probably go back and re-architecture your code. But no matter what happens, the point is that this will bring up all the containers for all the dependencies that your application needs in order to be tested, right? After you pass unit testing. And once those dependencies are up and running, I will run another Docker Compose service called staging. And this is where somebody wrote that this will run in a container again, some other types of tests that will verify from functional level my application, right? When my application is running. I'm using try catch here because no matter what happens, if it fails, I want to fail as an error, which would do without try catch anyway. But I want to remove the containers once I'm done because I don't want wasted resources. No matter whether it's successful or failed, those containers should not be running anymore. They should disappear and leave resources for somebody else, right? Because this is a fire do something and disappear type of approach. So once I'm done with my functional testing or whatever you want, type of testing that require application to be running, I can publish it, meaning that I'm going to tag it. In this case, I'm going to tag it Go demo release 2. Whatever the build number is, right? It will be now 2.2, I think. And I'm going to push it to registry. So it's the same thing like as if you're using Nexus, right? I'm going to push it in, and then from any other server, anywhere inside of my organization, I can pull that image and run it somewhere else. I did not set, normally I would have a third cluster that would be exactly the same as production cluster, having exactly the same services and everything, but smaller in scale, right? If my production is 100 service, then I don't need for production simulation to be 100, I might be fine with 3 or 5, right? But the only difference between production-like clusters would be in a number of instances. Everything else, exactly the same. But I'm skipping this part because simply my laptop has a limited amount of memory. So I'm going to skip. This would be exactly, this stage product would be exactly the same as this one. And this is production, meaning that I'm going to run Docker service update. Now, I didn't show you this before, but now imagine how you deploy today, right? Is any of you deploying by stopping your currently running instance and putting a new instance in its place? Anybody? Yes? You have downtime? You go Sunday, right, to do it because nobody's using your application on Sunday? Okay. This Docker service update Docker service update means that you can update any aspect of your service. And remember, service is not a single instance. Service can be as many instances as you want. So you can change anything. And in this case, particularly, I'm going to change the image. So I'm going to change the image of my release to be a newer release. Now, what would Swarm do? At the moment, I'm running only. No, let's just a second. Let me see, 697. So just to show you the point, I'm gonna. So my Docker service PS Go demo. I have one instance of a service, right? That I created before. Let me scale this because it will show you better how things work. Docker service scale, Go demo. I want how many? 5 instances. Right? And now 5 instances will be running inside of my cluster. The reason why I'm telling you that is that now when I execute Docker service update to update my instance to a new release, what Swarm will do by default is that it will employ something called rolling updates. Do you know what rolling updates are? Yes. Okay. So for those of you who didn't say yeah or nod your head or something like that, very quickly, rolling updates means that if you have 10 instances, for example, it would upgrade one instance, then upgrade the second, the third, the fourth. So at any given moment, at least 9 instances are running. You have no downtime, right? That's the worst case scenario. No, you can change that. You can say update 3 instances at a time, and in that case, at any given moment, 7 instances would be running. You know? But it allows you to upload without any downtime. So it will update. So I will update my service to a new release I just built, and finally I'm going to run another round of tests, in this case called production. Doesn't matter. What it matters is that somebody defined that the service called production in Docker Compose will run some production tests. So let's see whether that works. So I'm gonna run build now, and depends. Do you like logs or boxes more? Let's go for logs. Okay. So you can see what's happening now. Okay, it's getting cloning the code. It's gonna do exactly the same what I said. So it's cloning the code. It's gonna run unit tests, and for that it's gonna, since code is written in Golang, it's gonna use Golang image. Something happened. I don't know. Oh, it's gonna use Golang image. Imagine that it's using Golang image. Now it's downloading dependencies of my service, right? In this case, dependencies is, for example, MongoDB drivers and stuff like that, right? Everything it needs to run unit tests besides the code itself. Now, this depending on a network can last anything between a second and eternity. You can ask questions now. This is a good moment while I fetch my code.
All the images that we are running during the testing and such,
yeah,
are running on the. All the Docker images that we are running during the testing and the building process in Jenkins are running on the same Docker engines that we are running the slaves of Jenkins.
Yes.
But not in Docker Swarm.
Not in Docker. No, they're not running as Docker's.
Because we are using Docker
They're not
Compose.
running as Docker Swarm services, but I'm using Docker Swarm as a way to create agents as a service. But inside of those servers, it's running as Docker Compose stuff. You cannot really do this, at least not easily, as you cannot run your tests as a Docker service directly, simply because Docker service does not give you the output, does not wait for you to finish. That will change relatively soon. I'm not allowed to say, I promise I'm not going to say when, so there will be new modes to run Docker services. But at the moment, you cannot, because you will just get the ACK saying, I'm going to run it. You will not get the output, you will not know whether it failed or successful and all those things.
So the test will run on the same Docker engine as the slave.
As one of the slaves, yes. It can be any of the two, right? Does that answer your question? No?
Yeah.
Okay, you did this. Okay, so it used Go as base image. It ran all my tests. Here are the tests, right? It built the image. This is my image. And then it ran another set of, it created all the dependencies, meaning MongoDB running somewhere and all those things, ran another round of tests, destroyed the dependencies here so that they don't exist, push the image to the registry, they updated the production release of my service to 2.2 and run another round of tests. And the result is this. You can see here that the previous release is shut down and the new release 2.2 is in its place for every single of the 5 instances, right? If I was faster, I could have shown you that it would update one by one, right? But now it's already finished, so you see the end result that everything is updated, right? Now, I don't think I have many more slides, but I can answer any of the questions if I know the answer, which might not happen. So, do I have, no, okay. This was so fast that you probably don't understand what I said, so you can ask questions, right? This is the material I use for an 8-hour workshop, and people complain it is too little. So I understand it 40 minutes might be a bit confusing. So questions, if there are any. Yes, please.
I'm familiar with the theory a little bit. I really learned a few things about farms and all the things I didn't know. But I'm wondering, how do you use that in a real environment? How is your experience as a consultant or with your colleagues when you explain to use these features or this way of doing continuous delivery? How is the experience you have just implementing this in a proper
Are you filming this? That depends from company to company, right? I work for from anything from small, relatively small companies which are agile, which have both motivation and will to change, right? And I work with huge companies like banks, right, that have a willingness to stay alive, not to change. So it depends, really. I mean, we know that containers work well, right? Google proved it because it runs containers for 15 years, and you cannot get bigger than Google. Now, we might argue whether Docker is the way to go or no, but containers, I mean, it's going to stay. That's the only problem with containers. And the major problem that actually why many companies are not jumping into containers is that their architecture is usually not ready for containers, right? If you have a huge WebLogic server, you know, where you're dropping your WAR files, I don't know, you might be young, you might not know even what WebLogic is, right? Huh? Then kind of, in general, you can put the monolith into container, it's cool, you have benefits, but if you want to really use containers, you should jump into microservices, services type of architecture. And then sky's the limit.
So I have another question. So containers are good, but what about mobile games or mobile companies that they have to use, you know, it's a bit different because for compiling, you might need to use typical multi-platform that you need to build your code in different Linux versions. That's fine for containers, but maybe you need to use also Visual Studio, or you might need to use also, Mac.
I don't know. I mean, yes. I mean, so first of all, if you're talking about so a couple of examples you said, right? Docker, Microsoft is the main sponsor of Docker today. Docker is coming on or already came. I'm not following, correct me if I'm wrong, but it's around there with Windows Server 2016, right? It's lacking some of the key features. That's because simply Windows kernel is not prepared for, because containers exist, namespaces and all those things that we use to create containers that exist in Linux, and they really put a lot of effort to put it into Windows. Now, for macOS, Docker run, but it's not macOS native. I mean, it is, they say Docker native, but it does not run macOS applications, so you would need to go without Docker for that. But it's kind of, if you can solve 2% of your problems with Docker, then it's still worthwhile. No? It's similar, like one of you here knows, in one of the previous companies I worked for, like they had those conversations with the automation of testing, right? And then testers would say, I found a test that cannot be automated. Let's not automate it all, right? Kind of like type of attitude. I mean, you must have, you're talking about King, I guess, no? Okay, or anybody, kind of, you still have backend services that are running in your cluster somewhere that's hopefully not in Microsoft Windows, sorry, Microsoft, and all those things. So use it for that.
Actually, you can build your own container with this kind of limitations. Just use it as a service, say a cluster of Microsoft. At the end, you can manage it more or less like a container service that you don't care when it will be available on Microsoft.
It's more about building itself rather than services running container. So we can probably keep talking or start eating a
Pizza.
Yeah.
Okay.
Okay, few words to close. We are just starting. This is our second meetup. I would like to thank our speakers, but also to thank the co-organizers. Together with me, I'm Jorge. The bearded fella over there is Viktor, and there's also another person who couldn't come, Ferran. If you have any suggestion, you want to talk on the meetup, just drop a message on the meetup application, and we will get in touch. Thank you very much, and pizza is cold, so go there.